How much is planet Earth worth? Some things are said to be priceless, and we'd probably put the entire planet Earth in that category too. Still, some people have attempted to estimate its value. So how much would Earth cost on the interplanetary market? In 2020, Gregory P. Laughlin, an astrophysicist from Yale University, fired up his calculator and came up with a value of $5 quadrillion. He claims to have factored in the planet's chemical composition, average temperature, age, and suitability for life. According to his formula, for example, Mars would be worth just $16,816, about the price of a car. And Venus, where 96% of the atmosphere is made up of toxic carbon dioxide, would go for next to nothing. Laughlin emphasizes that his calculations are, of course, meant to be taken with a grain of salt. His real goal was to help us realize just how precious the treasure is beneath our feet. Since when have emotions been associated with the heart? The heart has long been a symbol of love. When someone does something with heart, it means they do it with pure emotion, not with reason, which might suggest otherwise. But why is this life-sustaining pump associated with feelings? More than 2,000 years ago, anatomical knowledge was quite different from today. People considered the heart the body's only vital organ and believed it was also responsible for thought. For example, Aristotle wrote that the heart is the seat of emotions, passion, and intelligence. And the brain? According to the Greek philosopher, its role was to cool the body and regulate sleep. Even then, however, scientists and physicians correctly suspected that blood vessels carried blood to the heart. So emotions like love and infatuation, when our cheeks flush and our knees tremble, were linked to the movement of blood flowing toward its center. Roman physician Galen later moved the function of thought to the brain, but the heart kept its symbolic role. Why do men grow beards? At first glance, the answer seems simple. The growth of facial hair is influenced by the hormone testosterone, which is present in much higher levels in men. Women have so little of it that it's not enough to grow facial hair. But why did evolution decide that men should have beards and women should not? Even Charles Darwin pondered this question. He proposed the idea that beards are decorative. They're meant to attract the opposite sex. But this isn't necessarily a clear-cut answer, since many women don't find bearded men attractive. In that case, stubble wouldn't help much in passing on genes. A few years ago, American biologists from the University of Utah proposed another interesting theory. Since men in the past were mainly fighters and hunters, beards may have served as protection. When the research team created a kind of impact simulator and measured the amount of energy absorbed by a blow to a smooth versus a bearded face, the results were clear. Beards, they say, can absorb at least 30% more energy and thus cushion the blow. However, it remains just a hypothesis, not everyone agrees with it. Would a compass work in space? On Earth, a compass reliably points us north. The needle moves according to the planet's magnetic field. But what happens if we take it into space? Would it be of any use there? A compass contains a small piece of material that is always attracted to the magnetic North Pole, even when we're standing in the southern hemisphere. And what if we're in space? Then it depends entirely on where we are. Earth's magnetic field extends about 100,000 kilometers from the planet, so within that range, the compass will still point toward Earth's magnetic north. But if we move beyond the magnetosphere, then the compass will latch onto another body's field, just like searching for the nearest mobile signal. Around the Moon or Mars, the compass would need to be very close, as their magnetic fields are weak. You're more likely to pick up the influence of Jupiter. And if we're not within range of any planet, then the compass will point toward the Sun. Its magnetosphere stretches across the entire solar system, though its magnetic poles flip roughly every 11 years. Still, in space, A compass won't be of much use. Navigating up there requires more directions than just the 4 we use on Earth. Can hippos swim? These bulky creatures with thick skin spend most of their day splashing around in water. That's why their name in most languages comes from the ancient Greek hippopotamos, literally river horse. But does that mean they can actually swim? Don't be fooled, hippos can't swim at all. In water, they move by running along the bottom. They enjoy spending time fully submerged and only need to surface for air about every 5 minutes. This isn't a problem even while they're sleeping. When in shallow water, their high-set nostrils stick out above the surface, allowing them to breathe normally the whole time. And if they end up in deeper water, they simply push off the bottom by jumping. What happens to our body in winter? Even though we may complain more often during sweltering summers, our body doesn't exactly welcome winter with open arms either. In fact, low temperatures can really take a toll on us. So what happens, aside from the risk of freezing? It's long been confirmed that we have higher blood pressure in winter. This can be caused by exercising less or eating more fatty foods. Our bodies also retain more salt, since unlike in summer, we don't sweat it out as much. Cold weather also causes our blood vessels to constrict slightly, making it easier for clots to form. That's why the highest number of heart attacks occurs in winter. Cold also affects the body's ability to fight infections, which is why people are more prone to illnesses like pneumonia. You can't catch a cold or the flu just from low temperatures, only viruses cause that. But those viruses love the cold and survive much better in low temperatures. Is sea level the same everywhere? When we want to express the height of a mountain or the location of a specific place on Earth, we use sea level as a reference. It seems simple, where the sea begins, that's zero. But is zero always the same zero everywhere? Elevation is defined as the vertical distance from a given point to the mean sea level. But not just any sea, typically, it's measured using the sea closest to the location. Using a different sea could yield a different result. Sea level is not uniform, it's influenced by the uneven composition of the planet and the resulting variations in gravitational force. Other factors include climate, air pressure, melting glaciers, salinity, ocean currents, and even temporary effects like tidal forces that cause the ebb and flow of the sea. In the end, the surface of the sea is a bit bumpy. So, if two mountains have the same elevation, it doesn't necessarily mean one isn't actually higher than the other. What was sold in the first vending machine? Today, vending machines sell almost anything and are a common part of the modern world. But they're not all that modern, they've existed since ancient times. Can you guess what people bought from the very first one? You'd find it in Egypt, as early as the 1st century AD. The first vending machine was invented by mathematician and engineer Hero of Alexandria. And its purpose was to make dispensing holy water in temples easier. You'd insert a coin into a slot, which would press a lever in the dispensing mechanism. That would release a precisely measured amount of holy water, not a drop more. This ensured everyone got their share and avoided disputes. Later known vending machines date back to 17th century England, where they sold snuff tobacco. Why does water feel colder than air? When it's 30 degrees Celsius outside, you feel pretty hot. But if the water in your bathtub is 30 degrees Celsius, it definitely doesn't feel hot. You'd probably want to add a bit more warm water. So what explains this paradox? Our average body temperature is around 37 degrees Celsius, and the body constantly works to maintain it. When the environment is only 30 degrees Celsius, it still draws heat from us. And water is especially good at doing this, because it has a much higher heat capacity than most substances. It takes a lot of energy to heat it up. When our 37 degrees Celsius body is submerged, it barely affects the water temperature, which stays cool and quickly draws heat away from us. That's why a dip in the water cools us down so effectively in summer. Air, on the other hand, conducts heat much more slowly and acts more like an insulator. The most comfortable air temperature for us is around 22 degrees Celsius, just enough to release excess body heat. But water at 22 degrees Celsius? Only a cold water swimmer would get in. How is it possible that a lemon floats but a lime doesn't? Have you ever tried throwing a whole lemon into water? We won't keep you in suspense, it floats. But if you do the same thing with its friend, the lime, it sinks. How is that possible? Your first thought might be that the lemon has a different shape. That compared to the rounder lime, it distributes its weight better on the surface. But even if you cut both the lemon and the lime into pieces or slices and toss them into a drink, they behave the same. The lemon floats, the lime sinks. This interesting detail is, of course, due to a difference in density. The lime's density is higher, although the difference is very slight. When American science popularizer Steve Spangler tried to calculate it the traditional way, by dividing the fruit's weight by its volume, he found the density difference between lime and lemon to be only 0.1 gram/ml. The water content is also very similar, about 88% in limes and 87% in lemons, as is the content of vitamins, nutrients, and other substances. The difference in floating ability between such similar fruits is, in a way, a quirk of nature.